Today we're going to learn how to apply rational functions in situations like the one we see here on the board, but also how to use that information to put these functions onto a graph. So let's go ahead and take a look at this first situation here. It says a group of friends goes to a restaurant and wants to split the cost of the meal. They reserve a room for $25 and each meal will cost $12. So we want to take this situation and do several things with it. The very first thing we want to be able to do is to take this situation and turn it into an equation. That way we can analyze what's going to happen as the number of people in this group changes. Because it's not always going to be the same amount every time, or they want to make plans and be able to change those plans depending on how many people come. So we want to be able to write an equation to model this situation, the average cost, per person as a function of how many people attend. And there's really two ways of thinking about how we do this. An average, we know, is the total cost divided by how many people attend. So if we look at the total cost here, we could say that the cost, or the average cost, is equal to, well, we know everyone is going to be paying $12, no matter what. So we could say that this is $12 per person plus the room cost of $25. So that would be the total cost for the meal. The cost of the room plus $12 for every person. But then we want to take an average of that, so we're going to divide it by the number of people, which would be P. So that's one way that we could write this equation. Another way we could write this is say, well, we know that everyone's going to be paying $12, but then they're also going to be paying a fraction of the room cost. So the average cost per person would equal the $12 meal that everyone has to pay if they're going to eat, plus their portion of the $25 room cost. And either one of them, they mean the same thing. If we look at this first one, if we were to divide out the p's from the 12p and the p, we'd get the 12. But we know 25 can't divide by p, so we leave it as the fraction. So either one of those would represent the average cost that everyone would have to pay as they come to this dinner. Well, we want to move on to the second piece and say cost if 4 people went to the dinner. Well, let's take either one of these and try to figure that out. I'm going to use this bottom one to help me figure this out. So the cost when 4 people attend would equal the $12 that each person has to pay, plus their fraction of the $25 that they paid for the room. So if I cut the $25 into 4, add that to 12, that's going to end up giving us $18.25. So if only 4 people attended, everyone would be paying $18.25 in order to cover the total cost of the room plus their meals. And if I increase that or decrease that, that's going to change how many people or how much those people are going to have to pay as they come. Well, are we ever going to be able to reach $12 a person if we include the $25 room cost? Well, let's think about that. The cost, or the average cost, dollars plus however much they had to pay depending on the number of people there were in the party. So if they're always paying $12 and something more, are we ever going to get to $12 per person? Well, the answer is no, it's not going to happen. Because they have to take their $12 and then add something to that. So it's always going to be $12 and something. Even if they have hundreds of people, they're all paying just a little bit to cover the cost of that $25 room. Okay, so $12 is the meal cost that everyone has to pay. But then they have to add on their portion of the room, so we are never going to get down to that $12 cost per person if you include the cost of the room. Well, let's think about what this would look like as a graph. So if I create my x and y coordinate system here, so the x coordinate is going to be the number of people that we have in this group, and the price per person is going to be our vertical, or our cost. So if we make a table of values, let's see what this would look like. So the number of people and the cost. Well, if one person came, and let's rewrite our equation up here, it was 12 plus 25 over the number of people. If one person came, they'd have to pay the whole $25 for the room, plus the 12 for their meal, they'd be paying $37 to go eat at that banquet room by themselves, which would be weird, but that's how much. Well, let's increase this to, what if 5 people came? If I take the $25 and divide it amongst 5, they're paying $5 each for the room. I add that to 12, I end up getting $17 if 5 people came, which is a lot better than the 37 if you go by yourself. Well, let's increase this, let's say, to 10 people. If 10 people come and split the $25, they're paying $2.50 each. So then I add that to the $12 for the meal. I end up getting $14.50. So as we increase the number of people, the average cost per person is decreasing. Well, let's say we end up having 25 people. If I take 25 people and I split $25 evenly, they're only paying $1 a piece, plus their $12 meal gives us $13 per person if 25 people came. Well, let's start to put this onto a graph. So if I go out just one to the right, and then count by 5s as I go up here, so I have enough room, I end up going about right there vertically. If I came out to 5 people on the people axis there, we've dramatically decreased to $17 per person. If I then double that and go out to 10, we're down to $14.50. And then if I double that to 20 and then go a little bit further out to 25, we're down to $13 a person, which is going to be about right there. So if we connect these up, we start to see a trend that as the more people we get in the group, the smaller the cost is going to be. Now, is there a limit or is there a boundary to how small that can go? Well, we said yes, that boundary was $12. So if I were to put that $12 mark in here, that becomes a boundary on where that graph can go. So yes, our price, or our cost, whichever way you want to call it, $12. And that becomes what we call an asymptote. An asymptote is a boundary line that we're going to approach as we get further and further out on our x-axis, or our people axis in this case. But if we look on this left side as well, we have another boundary here. Let's say the number of people, the boundary would be at 0. Because in the context of the problem, it doesn't make sense to go into the negative number of people. Then you have people disappearing, and that doesn't make sense in this case. So it doesn't make sense to go beyond $12 in terms of the cost it's going to be per person, but it also doesn't make sense to go beyond 0 people, because then you're not even having a party. So these two things, where we have the price or the cost equal to 12, becomes a boundary on that lower side, and the number of people equaling 0 becomes a boundary on that left side. And that can help give us some context as to how much money these people are going to pay as the number of people increases or decreases for the party.